All right, let's take a look at a problem with two conducting spheres. These two conducting spheres, each with charge Q, are connected by a wire as shown. Do any charges flow between the spheres, and how do their potentials compare? Well, the first thing we have to realize is when we connect them by a wire, all of a sudden they must be at equal potential. Anything that's connected by a conductor is going to be at equal potential. So once we do that, these have to be at the same voltage. That means if we look over here at Q1, V1 equals K Q1 over R1. Over here on the right-hand side, V2 equals K Q2 over R2. And because the potentials must be equal then, we could say that K Q1 over R1 must equal K Q2 over R2. Nice simplification we can make there. Divide K out of both sides. Therefore, Q1 over R1 equals Q2 over R2. And since we know that R2 is going to be twice R1, measuring those lines, we could figure that out, then Q1 over R1 must equal Q2 over 2R1. Or a little bit more rearrangement to say that Q2 must equal 2R1 Q1 over R1, or that's going to be just 2Q1. Q2 is equal to twice Q1, then we must have charge flowing from 1 to 2. So our charge must be flowing that way. We'll have charge flowing from Q1 to Q2. How do their potentials compare? They got to be equal. Equipotential lines for a capacitor. Draw the equipotential lines for the parallel plate capacitor below. Well, the first thing I'm going to do is it's probably easier to draw the electric field first, going from positive to negative. So I'll put in some electric field lines first, in green here. Electric field is constant between those. And then we know that equipotentials are always crossing electric field lines perpendicularly at right angles. So I could draw my equipotentials that way. And if this is 0 volts, then it'll be maybe 1, 2, 3 volts, 4 volts, 5 volts. We've got a constant electric field between these, but we don't have a constant potential. The potential is going to have a linear gradient from 5 volts down to 0 volts. All right, hopefully that gets you a good start on electric potential difference. We talked about electric potential energy and even some capacitors in there. Thanks so much for your time, and make it a great day, everyone.